Hi everyone, I'm Priya and today I'm here to present my project topic on face attendance system with anti-spoofing. So before going on to the actual project, first we are going to learn about what is deep learning. So deep learning, it is a subset of machine learning and it is a method in artificial intelligence that teaches computer how to process the data. This processing has been inspired from the actual human brain, and coming up is computer vision. So computer vision, it is also a field of AI. So it enables the computers to derive meaningful, for example there might be a text data set or audio file or video file. So we have to derive some useful information from these things. In these cases, then computer vision plays a critical role. So moving on to artificial neural network. So artificial neural network means it consists of a number of nodes which are connected to one another. So the artificial neural network is actually inspired by human brain. So it teaches the computer how to process the data. For example, there might be a one input layer consisting of n number of neurons and n number of hidden layers and one output layer. The input which is given to the input layer then passed to the hidden layer where the actual computations takes place, which is hidden to the outside world, and then these inputs are passed to the output layer. So here it is represented in a hierarchical manner. Next, moving on to the convolutional neural network. In this project we have used two algorithms. One is convolutional neural network and the other is LBPH, local binary histogram pattern. So a convolutional neural network, it is a type of artificial neural network which is used in image processing. We can use artificial neural network, but it has some disadvantages. For example, too much of computations. So CPU is not able to save and process all the images, which is having thousands or millions of images. It might not be able to process it. So in these cases the convolutional neural network comes to play. So we can use higher levels such as GPU or TPU. So the next disadvantages is the pixels. For example, a digit 2 is written, so a digit 2, it might be on any side of the matrix. So the whatever the 2 is present in that location, it will takes the matrix. So in these cases the pixels might not be accurate, too much accurate. It can take any pixels. So at the output layer, instead of getting a 2, I might get some other digit. So due to these advantages, we are using the convolutional neural network. In convolutional neural network, two features are applying. One is pooling and another is flattening. Pooling is used to reduce the dimensions. So by reducing the dimensions, we can reduce the overloading which is happening. And then flattening means converting of 2D array to 1D array, because the input layer, the neurons cannot take 2D as an inputs, and we are using ReLU, which is primarily used, it considers any negative value as 0 and the positive value it takes as same. So by applying pooling, flattening, so there will be less computation compared to the actual artificial neural network. And then we move on to, like, here you can see the flattening of a image. For example, there is a picture of a koala. Here we are extracting the eyes, nose, matrix from those, and then we are multiplying it those with heads, and whatever the digits it is there, we are flattening, so that whatever the 2D array we are getting, so it has been flattened and then passed as a 1D array to the input layer. So we can see that the benefits of using ReLU is it introduces non-linearity. So non-linearity means when a straight line it cannot cover all the points, then we are using non-linear. So here in non-linear, the curveness increases so that it covers most of the data points. So the non-linearity increases by increasing the degree in an equation. So as you can see, then by doing this, it speeds up training faster to compute. And convolutional, it helps in parameter sharing, and then it also reduces the overfitting. Next, move on to the actual part, spoofing. So spoofing means faking one's identity, and it can be used as various attacks such as identity theft. So in Instagrams or any social media, we have heard about phishing. It may be catfishing. Similar to this, in here they are phishing. So phishing is use of spoofing that attempts to steal somebody's personal information or credentials by having that volunteer that information. So here a person is trying to steal some of the confidential data of another person so that he can have the benefits of whatever the other person is using. For doing spoofing, I have used the convolutional neural network, and the optimizer used this Adam. We are having lots and lots of optimizer, for example, stochastic gradient descent and Adagrad. But there are some disadvantages related to this, and one of the best feature of Adam optimizer compared to other optimizer is it does adaptive learning at each step of iteration, and we are calculating the accuracy, and then to find the loss between the actual and predicted, I am using binary cross entropy. The main purpose is we want to detect whether the image caught is real or spoof. If you want to get more than one input as your output layer, or more than one or two, you can use softmax. So next we are using MobileNet. So MobileNet is nothing but we are whatever the weights I'm calculating, so it has to be stored temporarily so that I can fetch those weights like validation accuracy and accuracy, so that it could predict perfectly when I'm trying to use that to recognize whether the given image is real or spoof. Next we will be moving on to the building of anti-spoofing model. So for building an anti-spoofing model, I have taken some of the images from the Google Drive, and then I have created directories. In the directories I have two separate partitions, one for testing and one for training. So the training data is used to train the images, and the testing data has been hidden so that it could be used for future purpose. Next I have splitted the data. So the training data consists of real images and spoof images. Same applies for testing data also. So we are having these many number of images, for example 4229 in training directory and 951 images in testing directory. And next here you can see the real images and some of the spoof images. So coming down, this is for the training data. Same applies for testing data, the real images and the spoof images. So after that I am using the Keras model to build the model. So it has to be in a hierarchical manner. First is the input layer, and then the hidden layers, and then the output layer. So I am using the chain generator in order to do some pre-processing to the images, so that the quality of the images should be improved gradually and the shuffle will be randomly, so that it increases the more accuracy to the output layer. And then, as I said, mobile network, it basically works on training classifiers. And then at the output layers, I have using the sigmoid and ReLU. Sigmoid is basically used for having two outputs, true or false. And then here we can see the actual accuracy of our model, which is around 96.67%. And then we are using JSON. It is basically used to transmit and receive data between a server and a web application, which is in JSON format. Next, I have plotted a graph of training and the validation loss. And next we move on to the actual implementation of our model. Now in the actual face attendance system, we can see a graphical user interface having three buttons: register new user, login and logout button. On clicking register new user button, there will be another GUI which will ask you the basic details such as name, register number, section and branch. So a user can fill this details, and upon clicking the captured button, here we can see that user given with the register number is already registered. So which means the unique number, register number here made as the unique ID. So if I try to log in with any other details with same register number, then an error message will come that you have already registered. So coming up to the next part, we are having login. On clicking on login button, you can see a camera will pop up. It is basically to depict whether the person is real or spoof. Upon detecting a real face, it will mark as present, but if it finds any spoofing face such as this face, it will mark absent. Or I can take any other clarity images of my face. Yeah, here you can see, even though the clarity of the image is good, it is still printing as an absent. It is because we have trained this model to get an accuracy of 96%. So upon seeing any kind of spoofing, it will directly mark absent. So throughout this video, it will take only one time the face. So if you try to spoof at that time also, then you will be marked absent. So upon closing this, you can see login successful. Okay, then we will log out from this. As soon as I log out, you can see that the GUI has been vanished or destroyed. So here we can see the data set in which our images has been stored, and the attendance, the time, date and present for real image, and register.csv which maintains our credentials, so that if a user with same register number try to log in again and again, then the error message will come. So this is the working of our model. And by saying this, I would like to conclude my presentation. Thank you.